Upon the advice of several good books and my good friend Tim, the first big chunk of money I ever spent on this earth-sheltered house project was for a geotechnical analysis, and I'm glad I did. For those unfamiliar, this is a subset of civil engineering in which the soil and rock of a build site are analyzed. And this is not just a simple sieve or filter test, but rather an in-depth analysis that will provide the foundation for engineering and architectural decisions long down the road. And given my intention to dig up to 13 feet down to accommodate the sprawling layout of the structure, it would also guide me on whether I'd even be able to build on this site at all. This is where Sean comes in with his off-road core drilling vehicle. This is an impressive machine capable of getting anywhere they needed to go in any season. I didn't pull out a tape to measure, but the rear wheels on this thing spanned a good 4 feet each, so traction was not an issue at all. This is a purpose-built rig though, optimized specifically for the job at hand. Sean here would alternate between drilling downward with the hollow auger and pounding down the pipe, which would extract the core samples, which would then be sent to the lab and geotechnical engineer for later analysis. They would go down until 15 feet or refusal, the latter of which means, in this region, limestone bedrock. And this was repeated for the 4 test locations around where I intended to build the house. These core samples are sent to a lab, the results of which are then analyzed and reported on by Devin, my geotechnical engineer for this project. Devin's report was invaluable for this project. He did not simply regurgitate the results from the lab, but also wrote an in-depth report on his recommendations for how I go about preparing for and building my particular structure. This process tells us some crucial information about the build site. One is the depth to bedrock. This tells me, if I were to build here, roughly how much soil I can plan on being able to excavate before needing to get some jackhammers out, do some drilling or blasting, or simply stop there and create a mound for the structure. This is a big deal though. If we were to find bedrock at a few feet down, the site would be completely unsuitable for an underground structure. To haul in the material necessary to cover it would have been cost prohibitive. Just as importantly, we'll also find out about the types of soil at the various depths at the locations. Some soils are very difficult to properly compact. Others, no matter how compacted, do not have the load-bearing capacity required for a structure like this one. Given that the structure will be covered by about 4 feet of soil, the pressures exerted on the layers below is enormous. Sands, for example, drain and compact well, whereas clays hold water and some even expand when moist and contract when dry, a rhythm that will, over time, reduce a foundation to rubble. All went well though, and Devin's recommendations were highly valuable to me. Next up is excavation.